In this practice problems video, we try to find the derivative of the following 11 functions using the chain rule. We use both the version 1 and version 2. First, try to see whether you can find the derivative on your own, and then you can check your answers with the answers discussed in the video. So you can stop the video right now, and then you can try your problems first, and then you can look at the answers. Thank you. As the first problem, we have y equal 5x plus 4 to the third power. So in this case, what we do, we first find the inside function. We call this u. So if you call the inside function u, you can see this is simply u to the third power. So y equal, in terms of u, it is u to the third power. So we can write the two functions now. So y equal u to the 3, that is the outer function, and u is the inside function, which is 5x plus 4. So the main theory we use here is the power rule. So we know that the derivative of x to the n is simply n x. You subtract 1 from the index. So now what we're going to do, we take the derivative of the first function with respect to u. So using the power rule, this is going to be 3u subtract 1, 2. And again, this one, the second one, we're going to take the derivative with respect to x. First one with respect to u, the second one with respect to x. So if we do that, you can see this is simply 5 because derivative of 4 is 0. Now we can use a formula. So what the formula says, so derivative of the original function with respect to x is take the derivative of the function with respect to u and then multiply by the derivative of u. So that is a formula. So dy by du, we calculate that, it is 3u squared, and du by dx, we find that, which is simply 5. So it's coming here, and that one goes there. Now what we can do, we're going to simplify. So this is very easy to simplify. So we're going to multiply the numbers. So it is 15 u to the square, 15 u to the squared. Now we don't leave it like that. So there's nothing wrong with that, but the problem is you have to leave it using the original variable. So that means you're going to plug in back to u. So if you plug in back, this is going to be simply 15 u equal 5x plus 4 to the squared. So that is the answer for the first one. So this is the substitution step. So we're gonna substitute. Okay, let's look at the next problem. As the next problem, we have y equal square root 4x squared plus x, and it's very clear what is the inside function. So once you use the inside function, this is simply going to be square root u. So that means the two functions are y equal square root u. So we normally rewrite this one as u to the 1/2 because we need to know what is the power. And the inside function u is simply 4x squared plus x. So again we use the power rule here. So first one, we're going to take the derivative with respect to u. So this is 1/2 u to the, if you subtract 1 from 1/2, it's going to be negative 1/2. And take the derivative of the second function, of the inside function with respect to x. So using the power rule, this is going to be, you're going to multiply the two numbers. So it is 8x plus, if you take the derivative of x, which is 1. Now we are going to use the formula. So if it's the formula, it is dy by dx equal dy over du times du over dx. So if you plug in, this one is the first one, so we're going to use from that. So dy over du is simply 1/2 u to the negative 1/2 times du u over dx. So that is the second function. So we're gonna write the second function, which is 8x plus 1. Writing like this is actually incorrect, because what this means that you're gonna multiply the 1/2 u to the 1/2 only by 8x. That's not what we need. We need to multiply the whole thing, so that means you need to write a parenthesis around when you have more than one term. So that is the derivative, but we don't leave it like that. We're gonna if we can, we can simplify and then rewrite using the original variable. So that means we can write this one as 8x plus 1 to the derivative square root u, and then what you can do, you can substitute for u. You substitute for u, you're going to get 8x plus 1 over 2. In this case, u equal 4x squared plus x square root. And you can see that you cannot simplify this further than that. You cannot cancel 2 and 8 and get 4. We can do that because that's not a common factor. So this is the most simplified form of this one. Okay, so let's look at the next problem. As an next example, we have y equal 6x to the 4th plus 5x squared minus 11 all together to the 10th power. So as before, it's very clear what the inside function. This is u, so that means this is simply going to be u to the 100. So that means the two functions that we need, one is y equal u to the 100 using the u variable, and u equal inside function, which is 6x to the 4th plus 5x squared minus 11. Take the derivative of the first function with respect to u, which is very easy using the power rule, which is 100 u to the 99, we subtract 1, and take the derivative of the second function with respect to x, which is 24. We'll multiply the 2, so which is 24x to the 3rd power plus 10x plus 0. Now we can use the formula. So it is dy by dx equal dy over du times du over dx. So we're going to substitute, which is 100 u to the 99, and then we have 24 x3 plus 10x. So what we do now is we can substitute for u, so which is and then also you can see that there's a common factor 2 and an x, so you can pull them out just to find a simplified form, which is 200. We pull x, you get 1x, because you pull 2, and with 100 you get 200x, and then we have the leftovers is 12x squared plus 5. That's what you get. And then we have the u term, so which is 6x to the 4th plus 5x squared minus 11 to the 99 power. So that is the simplified form of the final answer. So let's look at the next problem. Next, we have a trigonometric equation. We have y equal cosine 9t plus 7. So if you are not familiar with the trigonometric functions, what are the derivatives of trigonometric functions, you can look at the video about derivatives of trigonometric functions, and you can find the link in the description. So in this case, again, we're going to figure out what is the inside function first, so which is u. So then you can see this simply becomes cosine u. Now the two functions are y equal cosine u is one function, and u is simply 9t plus 7. So let's recall one theory. So what are the derivatives of trigonometric functions? So here we need cosine, so let's write sine. So derivative of sine is cosine, and the derivative of cosine is negative sine. So we need the second version here, the derivative of cosine. So that means if you take the derivative, and you can see that it is dy over du, which is negative sine u, according to the formula, and then du over dx, just the power rule, which is simply 9. And also be careful here, the variable is not x, it is t. So that means we have to change this to t here. It's dt. So our new formula is dy over dt, not x, which is dy over du and then du over dt. So now we're going to plug in. So the first one, we know the derivative here, so which is negative sine u times du over dt is 9. So it can create confusion, so we don't leave the answer like that. What we do is we're going to move the 9 in front. So that means we can write our final answer as negative 9 sine, and the u is 9t plus 7. And you notice that there's no changes to the inside function, that stays there. So that's something we can notice. Nothing happens to that function, just stays there, only multiplied by the derivative outside. Okay, so let's look at the next one. Next we have ft equal e to the 1 minus 2t plus t squared, and again the variable is t here. So again it's very clear what is the inside function. So there is the inside function u, so that means this simply equals to e to the u. So that means the two functions are here. First one is fu, in terms of u variable it looks like e to the u, and then u is the inside function, which is 1 minus 2t plus t squared. As before, take the derivative of the first function with respect to u, so it is df over du, and we know what's the derivative of eu. It is eu again, because if you recall the corresponding theory, and you can see the derivative of ex is simply ex again. So that's what we use here. And then the derivative of u with respect to the variable t is, you can see 1 is a constant, so it is negative 2 plus 2t. Okay, so we have everything we need. Now we're going to plug in. So we have df over dt is df over du times du over dt. So that means df over du with respect to u, it is simply eu. It is coming from here. And then times du over dt, which is negative 2 plus 2t, and then we can rewrite the final answer using t. And then also we can do something, we can pull 2 out, and then once you pull 2 out, you're gonna get negative 1 plus t. We can write this one as t minus 1, and then e to the u is 1 minus 2t plus t squared. So that's the final answer. So let's look at the next one. So far we used the first version of the chain rule. So let's try to use the second version of the chain rule now. So, and you can see that the second version is still the first version. What we do is we do certain steps mentally now. So we don't show the steps right now. So we do quickly. So that's why the second version is much faster, because what we do, we ignore certain steps and we write the result directly there. So let's see how we can actually use the second version of the chain rule now. So we have the function hx equal 1 over 2x minus 3. So still we have to figure out what is the inside function versus outside function. So you can see clearly what is u is 2x minus 3. That means your function is simply become 1 over u. So that's the main function or the outside function. So we can write the two functions. So it is fu, which is going to be 1 over u, and the inside function, which is simply going to be gx equal 2x minus 3. This time we write gx, we don't write u here. So simple mental calculations. So what we normally do is we first write this is u to the negative 1, and then simple mental calculation says that the derivative of the outer function is it is the power rule, so it's negative u negative 2. So this will be useful. So we just do this as a mental calculation. Now let's see how we use the result. So the derivative of the h with respect to the original variable, which is x, is what it says that take the derivative of the outside function and evaluate at gx. So that means you still need the derivative of the outside function. So right now we know that it's negative u negative 2, but the way we write is different, and then multiply by the derivative of the inside function. So this is the major step here. So now what we do, we directly substitute now, because we know the derivative is negative u to the negative 2. So we don't write u now. What we do, whenever you see u, we directly write gx. So that is the difference of the second version. So it is negative. Instead of u, we directly write the inside function. So that's the main difference. And then negative 2, see the difference. So we don't write u here. And then g prime x, that means derivative of the g, which is 2. You really don't need the dot and the parenthesis. Parenthesis means the multiplication, but just to make it clear. Okay, so that's the answer. What we do, we write them without negative index. So that means negative. We write 2 here, and then we're gonna bring this down. That is how you use the second version of the chain rule, and you can see it is a little faster because we ignore a step. That's how we do. Okay, so let's do a few more examples now. So let's look at a natural log function. So we have y equal ln 5t square minus 2t plus 7. So we know the derivative of natural log. So derivative of ln x is 1 of x. And we also know that even if you take the derivative of the ln absolute value, there's still 1 of x. So that's something we learn in the derivative of log video. Okay, so again, it's very clear what is the inside function. That's u, inside function. So this is simply ln u. So that means you can write the outer function, which is fu, which is simply natural log u, and the inner function gt, which is 5t squared minus 2t plus 7. So here the variable is t, original variable is t. So let's write the formula now. So which is dy over dt equal f prime gt times g prime t. So that's the second version of the derivative. So, and then we know that the derivative of the outside function is simply 1 over x, in this case 1 over u, but what we do, instead of u we write gt. So that means it is simply 1 over gt times the derivative, which is derivative of g, which is 10t minus 2. Now what we do, we put the gt here. So gt is and then you can also simplify, so we can write 10t minus 2 over gt. Gt is 5t squared minus 2t plus 7. So that is the derivative of the function now. So you can see there's a shortcut here. The shortcut is you put the function in the bottom and the derivative top. So that's a shortcut version, and we discussed this in the 3 formula trick. So you can look at the video in the description. So that's a shortcut for doing problems like that. This is one of the formula. That's called the 3 formula trick. So that's a trick for log. Okay, so let's look at another one. Let's look at another trigonometric one. So we have a GD equals tan square theta, and you can see that here the original variable is theta. So you can see it is hard to see what is the inside function. So we're going to rewrite this as tan theta whole thing squared. That's what this means actually. That's the notation we use for that. And then you can figure out the two functions. So you can write this one as f, and then I'm going to call h theta inside function, and then you can see it's very clear what is the inside function and what's the outside function. So that's the inside, and f is the outside. So you can see the outside function simply, you can see if you bring this one as u, simply u squared, that's the outside function. So the derivative of that is 2u. So everything is very clear now. So So what we have here is, so we have fu, which is u squared, and the inside function, which is h theta, is tan theta. And if you recall the derivatives, d by dx tan x, and we know that this is simply the secant squared x. So that's the derivative of tan. So if you are not familiar with the derivative of tangent, derivative of trigonometric functions, and you can look at the video about derivative of trigonometric functions, and you can see the link in the description. Okay. So now what we do is we simply do a mental calculation, and we can see if derivative of f is simply 2u, and then you can see that we need that. So now let's try the formula. So the formula is dg over d theta is the derivative of the outside function evaluate at the inside function, and the times the derivative of the outside function. So since we know that the derivative is 2u, this is simply 2, and then we're going to put the inside function here. Inside function is simply tan theta. So we just write it there. We don't write u here. And to the 1, so we don't write the 1. And then the derivative of the inside function, which is tan, so derivative of tan is secant squared theta. So normally when you do trigonometric functions, we try to simplify, and in this case you can see that you cannot simplify this further, so your final answer is 2 tan theta secant squared theta. So that's the answer. So let's look at maybe 2 more. As the next example, we have a very interesting function. We have y equal natural log secant x plus tan x. So this is this actually we're going to derive a formula that you're going to use in Calc 2. So we can recall some of the formulas. So we know the derivative of tan, which is secant squared, derivative of secant, which is secant x tan x. Again, if you are not familiar with this, you can look at the video about the derivative of trigonometric functions. Okay, so let's try to figure out our function now. So the inside function in this case is secant x plus tan x. So we have the outside function fu is simply ln u, and then the inside function, which is gx equals secant plus tan, secant x plus tan x. So if you use the formula, dy by dx is simply, we know the derivative of ln, so which is, so what the formula is, what is that? F prime evaluate at the inside function times g prime x. But we know that the derivative of ln is 1 over u, but instead of u we write the inside function directly, so it is secant x plus tan x. We take the derivative, evaluate at the inside function. The derivative of ln is 1 over u, and then we write, so it's d by dx ln x is 1 over u, so we just write 1 over x, so it's, in this case 1 over u, we write it, and then multiply by the derivative of the inside function. So derivative of gx is secant, means secant x tan x, plus derivative of tan is secant squared x. Now we see whether we can simplify, and you notice that secant is common, so we're going to pull one of the secant out. So that means we're going to see that this is secant x. We pull one secant out, you're going to get tan x plus secant x divided by secant x plus tan x. And you can see that this is the same, so you can cancel these two. So that means you finally get as the answer secant x. So this is very interesting, and you can see it simplifies very well. So the derivative of ln secant x plus tan is simply secant x. It's a very interesting problem. Okay, so let's look at just two little complicated ones now. How about this? As the next example, let's look at k theta equal e to the 2 theta sine 3 theta. So you can see this is a product problem. So it's a u and v. So it's a product problem, and we know the derivative of uv is uv prime plus vu prime. uv prime plus vu prime is a plus sign. So let's try the formula now. So it is k prime theta is uv prime plus vu prime. So u, which is e to the 2 theta, and the derivative of sine 3 theta, so we have the prime notation, plus v, which is sine 3 theta, and the derivative of e to the 2 theta. So now this is where we use the chain rule. So it is e to the 2 theta, and we know that the derivative of sine is cosine, and then multiply by the derivative of the inside function, which is 3 plus sine 3 theta. Derivative of exponential function, you repeat the function and then multiply by the derivative of the inside function, which is 2. So that's the derivative. So it's very simple. So this is the derivative of the first function. This is the derivative of the second function. Okay. So now what we do, we normally try to take the common factors out, and you can see e to the 2 theta is common. So when you pull it out, you're going to get 3 cosine 3 theta plus 2 sine 3 theta. So that is the final answer, and you can see that you can do that very quickly. So let's do one last problem before we finalize this. So let's look at the next one. So we're gonna write step by step directly here without writing the formulas. So y prime, derivative of y, is simply an exponential function. When you have exponential function, you repeat the function without any changes. So that's the first one. And then you multiply by the derivative of the inside function. So in this case, d by dt, inside function is 1 minus 2t minus t to the 4 square root. And here you don't need a parenthesis because there's only one function here. And then now we take the derivative of the second function. So e 1 minus 2t minus t to the 4, no changes. Now multiply the derivative of the inside second function. So it's 1 half. Because we know the square root means 1 half. It is 1 minus 2t minus t to the 4 to the negative 1 half, and then again multiply by the derivative of the inside function. Now what we do, we're going to take the derivative of that one, so that means you're going to get e 1 minus 2t minus t to the 4, and then we have here, we can write this one, if you want, we can bring it down and we can write this one as 2 1 minus 2t minus t to the 4 square root, and then take the derivative here. So it is simply so when you take the derivative of these two terms, so you're going to get negative t negative 4t cube. So that's the answer. But what we normally do is we can write in a more simplified form. So that means you can see, you can cancel 1t here, that means 1 2 here, that means you're going to cancel that, and you're going to cancel this, so you're going to get 2 here. And we can also pull the negative sign out. That means your final answer is negative. So once you take 2 out, you're going to see that you're going to get, so we have a 1 here, so that means your answer is simply 1 plus 2t cube divided by 1 minus 2t minus t to the 4 square root times e to the square root 1 minus 2t minus t to the 4. So you can write this directly using step-by-step methods. First you multiply by the derivative of the first inside function, then you multiply by the derivative of the second inside function. So that's the answer. So now you can practice those problems given as at the end. So and then you can match your answers with the answers given. Thank you for watching. Now you know how to find the derivative using the chain rule using the both versions 1 and 2. So see whether you can try the derivatives, you can find the derivatives of the following functions, and you can find the answers in the description.